Cement production, I think we are all familiar with cement. How many of us have worked with cement before? Okay, so at least we have about 3 or 4 people who have ever worked with cement before. So cement is really common, but cement alone doesn't work. Mostly we use it as a binder for something, whether binder for sand, whether binder for wood particles, or other product production. So this is just a scheme to show how we produce a cement to be used in at least as a binder in mineral bonded composites. So in this scheme, what normally happens or what is happening, and the scheme can also differ depending on the company, how structurized their things are or how complicated their machine systems and operating systems are. So, but this is just a basic idea what is happening, and basically there are 4 main processes that are occurring in this picture. One is the raw material milling and processing. Then the first part, so when we come to this picture, we have, for instance, a source of a raw material which is limestone. So when we get the limestone, mostly they are in bigger particles or they are very big. Like when you see these limestones, they are very big, and we need to first break them down by crushing into at least something smaller. And after the crushing, it's not only the limestone that we are producing our cement from. We have also a source of iron. So we add a source of iron in our product and to produce the cement. So after this, we also mill it. Then we come to the homogenizing. So what happens in the homogenizing is we are trying to form a uniform mixture between the limestone and the iron, or the source of iron. So we have something, but they are still big, and actually they are not cement yet. Once you have still combined these two, they are not cement yet because they need to go into another process. And we come to the actual process where we are going to heat them up. And here, what happened with the calcination is that after getting the homogenized material, the calcination is basically just applying heat, high temperature heat. And normally we apply temperatures above 825 degrees Celsius. And most companies are, from literature, most companies try to burn around 900. Others could go beyond 900. But always the temperature is mostly above 825 degrees Celsius in calcination. That is why there is also a lot of carbon dioxide released from this whole process. And after the calcination, we have what we call the clinker. And this is how the clinker looks like. So the clinker, when it's hot, you see a picture of it, so because it's burnt really under high temperature. So the clinker, when it's hot, and mostly when it's cold, it's like this. So we cool the clinker down in here, the cooling process, then we store the clinker. But the clinker still looks big. And when you have a smaller particle size, it's easy to activate or it's easy to react because they have what? Much larger surface area than when we have bigger particles. So what happens is the clinker yet is not, we have almost something that is comparable to cement but still in bigger, so we need to mill it down. But the cement alone reacts really faster, so we need to add some additives before the milling. And what happens with the additives is mostly here, we add gypsum. We saw the gypsum bonded board before, but we are adding the gypsum as an additive here. And normally what happens is we add 3 to 5% of gypsum. And in some companies, they also add sodium oxide or potassium oxide as an additive. But the main additive that happens here is the gypsum. Sometimes the raw material comes with potassium oxide or with the sodium oxide. But the main additive here is gypsum because there is no gypsum from the beginning. So we get to know why we add the gypsum. Because we said we can produce also some bonded, mineral bonded composites from gypsum, but in this production, we have also gypsum in there. And we add mostly 3 to 5% of gypsum in this process. So from there, after our additives, we come to the final milling. And here, we try to mill them into that powder form that you see. So very, very fine particles for them to get larger surface area for reaction. Then to the storage, then to the filling of the bags, then to our usage. Any question or Something about the production that is not clear? Or to this process? Okay, if there is no question. So here we are now going to see something about the composition of the cement material that we have. So here I divided the components into two, where we have the clinker, the components of the clinker, because we said once you have the clinker, it's that one that you are going to mill to produce the final cement, but we also have some additives. So these are some of the additives that we are talking about. So we have the gypsum, we have the potassium, we have the sodium oxide. That can be an additive in the mixture. Then we have the main component of the cement or the clinker. We have the tricalcium aluminate, we have the tetracalcium. So, but normally in our fields, we normally try to use these short forms, the C3A, the C4AF, and we have the C2S, then the C3S. And what happens here is you can see the majority of it is the dicalcium silicate and the tricalcium silicate. They together makes more than 70% of our cement composition. Then we have also the C3A and the CAF4. So it's basically, these abbreviations are basically from this. So the C is just for calcium, then A is for aluminium. Then here is also similar, the F is for iron, so the C and A are still the same. F is for iron, and here the C is for calcium and the S is for silicate. Yeah.
Sorry, Brian. When you say cement, you mean Portland cement?
Yeah, Portland cement that we are talking about here. And then we have this composition, but they can also change. This composition can change depending on the company producing or the source of limestone and the source of even the mining or sand that we are adding in there. So this composition can change also. Because I've seen in certain compositions where we have even 45 and somewhere 25, but mostly these two mostly contains the majority of it, and we are going to see at least from the structure